This is data analysis in a nutshell. So this is for biology EEI students who are having to try and decide how to set up their data and what to collect in order to get some good data that actually measures and looks at the independent dependent variables that you've planned on. So it's going to be slightly different for every group, but I'm going to try and take it through an example of one from an experiment you're not doing this year. So to begin with, when we do data analysis, we have to think about what we need to measure. This is why on your planning proposals, I made sure that you guys discussed and looked at what is your dependent variable, what's your independent variable. In other words, what are you actually trying to find? Now in this example, we have an osmosis prac. So these kids were actually trying to see if changing the concentration of salt in a solution, think of it like seawater, if you put potato cubes into different concentrations of solution, will it change how much they lose or absorb water and therefore their size? Now all of you know that if you sit in a bath for a while, you'll get a little bit wrinkly. Well, if you go and swim all day in the beach, your wrinkliness will change. In other words, the concentration of the salt in the water you're soaking in will affect how you absorb or lose water. And that's what we're looking at here in this potato prac. So first of all, I asked them what's their independent and dependent variable. Well, the thing that they're changing is concentration of salt solution. The thing that they are measuring, if they're trying to look at how much water they lose or absorb, well, what do you think they would measure in order to look at water absorption? The easiest thing to measure is the change in the mass, because as you lose water or gain water, you're going to be changing mass. And that's exactly what they did. They looked at the change in mass. Now, to get the change in mass, you actually need to do a little bit more. You don't just measure a change in mass, you actually have to measure a few more things to figure out the change in mass. And we're going to have a look at the raw data tables that they set up to figure out the change in mass in every one of their different concentrations of salt solution. Okay, so here we have a spreadsheet with some raw data in it. Remember that I told you that they wanted to find change of mass. Well, there you go, change of mass. But in order to find the change of mass, you actually have to gather other data to do that. You have to know what your initial mass is, then you have to know what the final mass is in order to figure out the change of mass. So this is what we call raw data, the data that takes us on the journey to get us to what we want to find out. In this case, change in mass. You're going to have to think about what raw data you have to collect in order to get to the answer or the dependent variable that you're actually trying to measure. And you have to think about that very carefully and think about how you're going to set up your data tables, because on all of your data tables for your raw data, you have to have your independent variables and your dependent variables. So here it is color-coded. Here are my independent variables. I changed the salt concentration. Here is the dependent variable I'm aiming for, change in mass. And there it is worked out. But in order to figure out that change in mass, I had to collect data on initial and final mass. So you have to think about now how you're going to set up your tables for raw data. They have to have your independent variables, all of your independent variable groups along the top, all of the different things that you have to measure in order to get to your dependent variable down the side, and you have to have this multiple times over and over so that you collect lots and lots of data. That's the last thing I'm going to finish off with this video. If you don't collect lots and lots of data, not just one run, you have to do multiple trials, otherwise you will have a lot of error in your data. You won't know whether it's correct or not until you repeat it over and over again. Have a look here. Here is the 0% solution. Now on the first time they did this, it changed by went down by 0.28. On the second time it did that, it went down by 0.2. then it went down by 0.1, then it went down by 0.08. So every time they did this trial, it changed slightly. There was a little bit of error in there. Have a look at the next one here for 0.5. First time it went down by 0.18, then it went up by 0.1. Then it didn't change in mass at all. Then it increased by 0.06. This one here, where they had multiple trials of 0.5, they actually had a huge amount of variability in their data compared to the 0% solution. In other words, they weren't able to repeat this experiment over and over again exactly the same. There's a lot of error in there. Now, how are they to know that if they only took one trial? It is really important that you have at least a minimum of five trials so that you can actually know for sure if your data is accurate and do some really good statistical analysis on it. Okay, that's the very first step. Get your raw data. Make sure you set up tables that get you to the dependent variable answer that you are looking for. And those tables have to include the measurements you need to take in order to calculate the dependent variable that you want. Okay, that's the very first step. The next one is, how do you make sense out of that data?